Okay, so what slash value you will use between router 1 and ASA firewall, guys? 30. So let's say here network is 192.168.0.0/30. One on router and dot two on ASA firewall, because how many valid IP addresses I have here? Only two, right? And second network is going to be what? 192.168.0.4/30. I will use 8 in another building, right? 9 somewhere else. So I have multiple subnets with two valid IP addresses as well, and I have multiple subnet with 254 valid IP addresses as well, right, guys? Next are available next subnets I can use at different branch, at different location, or in different building. So let's suppose this is my building one. Let me assign IP on this interface also. This interface IP address is dot one, dot two on ASA firewall. What IP address you will configure on this router interface? Dot first valid IP address from this subnet. What will be first valid IP address from this subnet? Dot 5. 4 is the network ID, na? So first IP address is going to be 5. Second means last IP address 6. Done. Now, guys, tell me, may I need to configure something on a switch 1? Should I configure anything for connectivity? For connectivity between building 1 and building 2, your requirement is PC1 and PC2 should be able to communicate with each other. On access means on switch. On switch. On switch, nothing, right? Because by default, switch port are up. Yes, enable. You don't need to even run no such command. So ports are up and both ports are part of same VLAN. So that's why they can communicate with each other. So guys, subnet in building 1 is 192.168.1.0. Subnet in building 2 192.168.2.0/24. Last IP address is the gateway IP address, and DHCP is enabled for N devices. Between router 1 and ASA firewall, my subnet is 192.168.0.0/30.1 is running on router side, .2 is running on firewall side. Between ASA firewall and router 2, I'm running 192.168.0.4/30.5 is running on router side, and .6 is running on firewall side. If you want to see the MAC address, I can show you the MAC address of each device as well. So don't worry, we'll see at the time of packet flow. So now let me turn on these devices. Yes, any question? Yes, brother, ask me, because now I am going to ask you question. Yes, based on the network ID. Which network? All networks are different, na brother? Both network are different. This one and this one. Both are different network, na? So IP address is if this is the IP address 192.168.1.1/24. Tell me what will be network ID? 0/24 and PC2 IP address is 2.1. So what will be network ID? So both network are same or different? Different. So both are different. Here you can see slash value is 30. Here also slash value is 30. Right? Means submit mask 255.255.252. Block size is 4, na? Yes. So my first network is 192.168.0.0/24. Second network will start from 0.4 slash 30. So this network and this network both are different network. See the network ID now. Third network is going to be what? 192.168.0.8 0.8/30. Next network 0.12, then 0.16. So you are adding block size in fourth octet to find network ID. Next network ID. Clear, bro? Both are different network. Any other question? Yes. Any other question? No? So okay, let's begin. So I have turned on these devices. First of all, tell me when I will configure IP address on PC1, what will happen, guys? When I will configure IP address on PC1, PC will PC1 generate any message? Gracious ARP. Very good. Why? Very good. To find duplicate IP address. This IP address is unique or not? And guys, in the Gracious ARP, what will be source MAC address? PC1 is going to generate Gracious ARP. What will be source MAC? Source MAC address of PC1, na bro? PC1 have MAC address. PC1 destination MAC. All F. In the MAC address, guys, last character is F. So 12 times F is broadcast address. Source IP address. PC PC have not assigned that IP address. It is checking duplicate, but still it is going to put their IP address. Source IP address is 192.168.1.1. No. Source IP, but it have not assigned this IP address till now on the interface. Also, if it will not receive the Gracious ARP within the time, within the expired time, it will assign that IP address. If it will receive the reply, then it will drop it. So destination IP address will be what? No, 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 no. Not broadcast, no, brother. It is forwarding to 192.168.1.1. Now, who will generate reply to this ARP? This is a Gracious ARP request. If there is someone who is using this IP address, but if there is no one, then no one will generate reply. So PC1 will get to know, okay, this IP address is unique IP address. After that, it will assign to their interface. Got it? This is first step. Now let me do one thing. Let me configure IP address on router interface, guys. Let me access this router here and pull up the lab. And let me configure IPC. Don't worry about the configuration. I will give you one PDF for basic configuration, but you can follow. See, like to configure host name. You don't need to learn anything because you need to run enable command, then config team, configure terminal command. Then you will goes in, you will enter in global config mode. There you can configure everything, right? This is actually, you can say, configuration mode. This is view mode, right? You can only see the configuration. So if you want to configure something, you have to run command configure terminal. So this is configuration mode where I will do the configuration of router. Now I need to configure interface, or before that I can say host name to change host name. So host name is R1. Now you can see name of router is R1. Now let me save the configuration, do right. Interface E0/0. E0/0 is connected with which device, guys? Switch 1. And by default router interfaces are down. So that's why I have run command no shutdown. Now I am saying IP address. What happened? I think. Wait, bro. I did one mistake. Okay. These are switches, but I will use it as router. No problem. E0/0. I'm saying no switch port. See, we have two types of switch. One is layer 2 switch, guys, and another one is layer 3 switch. Till now, whatever things we have discussed, that was layer 2 switch, right? Now let's understand some basic thing about layer 3 switch. Layer 3. See the difference first of all. Call. Yes. Layer 3 switch. So by default, layer 3 switch act as a layer 2. Means by default, both switch layer 3 and switch layer 2 both are same. If you want to use it as a layer 3 device, layer 3 device means a device who can perform routing, means a device who can connect multiple network together, right? This is task of, by the way, router, right? Connecting multiple network together. But routers are costly. Routers are costly. So actually, we are looking for some one device who can perform routing and switching both. So that is my layer 3 switch. But definitely this device don't have capability to do all tasks that router can perform. This layer 3 switch cannot perform all tasks of router, but this layer 3 switch have capability to perform one task of router, that is routing, right? So in the layer 2 switch I have added routing features. When you will learn the routing, don't worry, routing is very interesting topic, guys, very interesting and very important as well. So we'll spend lots of time on routing. We'll play with routing. Oh, path manipulation, filtering, I love. Okay, so layer 3 switch means a switch who can perform switching, means forwarding traffic on the basis of MAC address as well. So it can forward traffic on the basis of layer 2 as well, on the basis of layer 3 as well. By default, layer 2 switch never check IP address, right? When it will receive the traffic, it will check destination MAC. First it will learn the source MAC, then it will check destination MAC. Okay, destination MAC is this one. Let me check my MAC address table. It will look up for that MAC address. Is there any exit interface available for this MAC address? Yes, exit interface is E0/1. So let me forward it from here. Switch layer 2 switch is not going to check even IP. switches are going to open your packet till layer 2, right? Like your actual data have multiple headers like transport layer header, then IP header, then Ethernet header. So switch is going to check only what? Ethernet header. Switch is not going to open IP header. Switch is not going to open transport layer header, not data. It will only open Ethernet header, and on the basis of information inside the Ethernet header, it will take forwarding decision. Then guys, router is going to check layer 2 information as well. First destination MAC, then it will router is going to remove this header. After that, router is going to check destination IP address in the IP header. What is destination IP? Then it is going to check their routing table. It will compare that IP address with their routing table. If route is available, then again router is going to add layer 2 header, and it will add destination MAC address of default gateway, means next hop IP address. For router number 1, next hop is ASA firewall. Next hop is ASA firewall. So whenever router 1 is going to forward traffic to ASA, doesn't matter that traffic is for whom, for router 2, for switch 2, for PCs, for internet, every time destination MAC will be the MAC address of default gateway. The reason, whatever network router 1 is going to learn, it will learn from ASA only. Yes or no? Like guys, this network 192.168.2.0, who is going to tell to router number 2 about this network? ASA firewall, right? To configure a network in the routing table of router, you have to set exit interface. You have to find exit interface, and guys, exit interface should be reachable. Means for router 1, sorry, next hop IP, not exit, next hop IP. Next hop IP address should be reachable. As router need what? Exit interface. Exit interface. Exit interface is required for directly connected network. If network is directly connected with me, then I will directly check what? Exit interface. But if network is not directly connected with me, then next hop IP address. So tell me na, this network is directly connected with router number 1? Yes or no? Tell me guys, is this network connected with router 1? No. That means to configure this network in the routing table of router 1, I need what? Next hop IP address. Means I have to tell to router 1, brother, actually this network is toward this IP address, and you are already reachable with this IP address, right? So do one thing now, whenever you will receive traffic for this network, forward it to your next hop, which is 192.168.0.2, right? Getting my point guys, what I am saying? Is it clear? Yeah, tell me. No, what I am saying, brother, that let's say I want to configure 192.168.2.0 network, which is running in building 2, right? So if I want to make communication between building 1 and building 2, I have to install both subnet in the routing table of all router, even in the routing table of firewall. Means these all devices should have information about the network. Then only these devices can forward packet. Like let's say in this scenario, PC1 IP address is 192.168.1.1. Let's say PC1 want to communicate with PC2. Source IP 192.168.1.1. Destination IP 192.168.2.1. Right? PC1 is going to forward it to their default gateway. Means destination MAC will be the MAC address of this interface. Source MAC will be the MAC address of PC1. Source IP, PC1 IP, destination MAC IP, PC2 IP. Then it is going to check their ARP table, that in the ARP table MAC address of my default gateway is available or not. If MAC address is not available in the ARP table, then it will call to ARP protocol. that please find MAC address of 192.168.2.1. You will configure default gateway IP address on PC, or DHCP server will configure it. But this machine need both default gateway as well as IP address, even DNS server IP address. So if destination MAC is available in the MAC address table, it will directly encapsulate frame. If destination MAC is not available in the MAC address table, then it will hold this packet and first send ARP request message, and router will reply. Router will generate ARP reply, and this is how PC can resolve MAC address. After that, it will send this packet to router. Guys, when router will receive it on which interface? E0/0. What router will do? Tell me the process. What router will do? It will check routing table. Yes, it will check destination. Destination is 192.168.2.1. Then it is going to check their routing table. In their routing table, there are only two network. One is 192.168.1.0/24, and one is 192.168.0.0/30. For this network, exit interface is E0/0, and for this network, exit interface is E0/1. So router is going to compare destination. Destination is 2.1. Oh my god, there is no any route available. There is no any route available. So router is going to discard it. Router will drop it simply. If route is not available in the routing table, drop the packet. But as someone has sent the request, so router have to inform at least PC that brother, I am going to drop it, right? I have dropped it. So router will send one error message. So let's say if you are pinging, you will get destination host unreachable error. Destination host unreachable error means my default gateway is telling to me that I don't have route, brother. I don't have route. That's why I have dropped the packet. So router is going to generate one message to inform PC that I have dropped your packet. So on router number 1, actually we need to insert this route, means where is the network ID? This route in the routing table of router 1. This is R1 routing table. I need to insert this network in the routing table of router 1. I have two options. One is static, another one is dynamic. Static means configure network manually on the router, means manually on this router I will configure this network. And dynamic means I will run one process on router, and that process is going to exchange routes, means all routers are going to share their directly connected network with their neighbor device. Like router 1 is going to tell to SA firewall, brother, I have two network, one is this one and one is this one. Okay, ASA will learn this network. Okay, whenever I will receive traffic for this network, I will forward to you. So it will, firewall will install this network in the routing table, right? Next hop will be router number 1, and then ASA is going to forward that information to router number 2. Now router 2 will also insert this network in the routing table, and next hop is ASA. Means for router 2, network is reachable through ASA firewall. On ASA, network is reachable through router 1. Because actual network is connected with router number 1. So router 1 will advertise to router number ASA. ASA will advertise to router number 2 if I have any other device. So it will, router 2 will advertise to router number 3, like this. So we will talk about routing later, don't worry. For now, manually I am going to add one network here, and before that, on the router, so IP interface brief, you can see we don't have any IP addresses on any interfaces. So I am going to configure E0/0 of this router. IP routing. Actually, you know, this is layer 3 switch. I am using it as a router because right now just I am teaching you routing. I will replace this router later. By mistake, and I have added layer 3 switch. So I thought, okay, that is also fine. It can perform routing. So today concern is to understand packet flow. Now let me do one thing. Let me configure IP E0/0, and say no switch port and IP address. What will be IP over here? 192.168.1.254. Subnet mask 255.255.255.0. Done. Now I have configured this IP address, so this router is going to calculate network ID of this IP address, and it will make one entry in the routing table. So IP route. Yes, you can see the routing table. There is one entry. This is local entry. This is network entry. Local means their IP address. What IP address you are running there. Then guys, there is one network. Which network? 192.168.1.0/24 is directly connected on which interface? Read this all information very carefully, okay? Because in troubleshooting, it is going to help you, right? When we will do the advanced configuration like OSPF, BGP, guys, that time you need to troubleshoot. Many times you will see you have configured the everything, now don't know why ping is not working, so you need to troubleshoot. So first you have to understand how to read the output of each command. Whatever command I am going to use on this router, like show IP interface brief. So if I am running this command, what output I will get and how to read this output. Like you can see it's saying on Ethernet 0/0 one IP address is running, which is 192.168.1.254. Okay, this is okay, that means IP address is configured over here. Method is manually, means it is a manual IP configuration. It can be from DHCP also. If your device will get IP address automatically from the DHCP, then method is going to be dynamic or DHCP. Then status of this interface is up and line protocol is also up. You know the meaning of line protocol, you know the meaning of status. Status means, guys, your interface is up. Line protocol means your next hop is up. So whenever you are going to troubleshoot routing issue, every time you have to check that next hop is correct and reachable or not. So if next hop is not reachable, then please check protocol, that protocol is up or not. Because if protocol is up, let's say there is some issue with cabling, cable is fault, right? Actually this cable have, two types of data. Like this port is receiving data as well as transmitting data. So TX and RX. Let's say RX of this cable is wrong, and that time on router number 1 you will see even line protocol is up because cable is working now. TX1 port is working, because of that line protocol is up, but there is no reachability. So customer is complaining that there is no reachability, brother. What you are doing? Please troubleshoot it as soon as possible. Now just suppose that you are network engineer in a SpiceJet, and guys, there are lots of people in the queue for boarding pass, and you are the managing, right? And their server is down because of this issue. Just suppose because of this issue their server is down. So you will have lots of pressure. How I can troubleshoot it as soon as possible? Even you will work in a small company, then also, brother, network troubleshooting is very bad headache. So to troubleshoot the network, you have to learn each and everything, all theory parts correctly. You have to read the output. So on this interface, this IP address, this interface is okay for IP address, method is manual, status is up, line protocol is up. IP address is also correct, next hop is not reachable. Oh, how you are going to troubleshoot it? Then I know blindly I need to change cable because there is problem. I need to actually change connector. Most of the time what I am facing, that connectors are getting more damage, guys. So maybe once you will change the connector, you will see now there is connectivity. So sometimes we don't need to check all configuration of router, where is the fault. First try to check layer 1 information, then layer 2, then layer 3, layer 4. This is the step for troubleshooting. What is OSI model in the production network? In the production network, guys, OSI model is troubleshooting from physical to application. Again, let's suppose these two networks are not able to communicate with each other. I will start troubleshooting from PC1. Like, I will check the PC IP address, I will check default gateway IP address, I will check ARP table that this machine have MAC address of their default gateway or not. Then I will ping to my default gateway, the default gateway is reachable or not. Then only I will move to router. This is not like if someone have complained that there is no connectivity between PC1 and PC2 or building 1 and building 2. You are going to access the router and you are going to start checking configuration, because in real time, brother, you will have lots of configuration in output in the running configuration. So you will run run. Now there are many output, even you cannot check it. So you have to filter the output. In real time, I cannot run this command. See, I want to see IP address on the interface. So if I will run this command, show IP interface brief. So in real time, guys, I will have, let's say, 1000 number of interfaces here. This is one switch. Some are assigned, some are not assigned, some are configured, some are not configured, some are shut down, some are no cert, like that. So I can actually filter it. I can say show IP interface brief and then include only assigned interface, let's say. You can use actually any keyword from here. So I am saying unassigned, so it is showing me all unassigned port. Or so run. If you will run this command so run, you will have lots of configuration. Now let's say you want to see the IP address on 0/0, means with the help of this command, so IP interface brief exclude unassigned. So it will exclude all unassigned interface. So here I cannot see the subnet mask, what subnet mask I am running. So maybe if my subnet mask is wrong, so I need to check running configuration. So I will run command so run, so running configuration. Again, in so run, I will have lots of configuration. So it will be very difficult to find the interface, and then I can check what IP address is running on that interface. Like this, here you can see on interface, where is interface? Yes, this one. E0/0, this is my IP address, this is my subnet mask. But I can filter the output. I can say so run interface E0/0. So it will show me the complete running configuration of this interface. So if I am troubleshooting this interface, I will check this configuration first. Here I am able to see the IP address and subnet mask. And even I have required output only, not the entire output. So in real time, you don't need every time to check complete running configuration, and you cannot check, right? It is going to be very lengthy. So on the router, I have assigned the IP address. Now I am going to do one thing. I am going to enable DHCP. So guys, see, to enable DHCP on router, again here you need to create one pool, right? Where you are going to define network ID, subnet mask, default gateway IP address, DNS server IP address, everything. So you need one database. So we are going to create the database with the help of DHCP pool. So I can say command IP DHCP pool and then name of pool. Let's say name of pool is ccna. And now I am going to say network. What network? 192.168.1.0, 255.255.255.0. And in real time, let's say you are creating pool for building 1. So name should be what? Building 1. It will help you while troubleshooting DHCP. So IP DHCP pool and say building 1. Now I am going to define network 192.168.1.0, subnet mask 255.255.255.0, default gateway IP address 192.168.1.254, last IP address from the subnet, DNS server IP address 8.8.8.8. Do you want to define anything else? TFTP IP address. Even you can define TFTP IP address with the help of option 150. We will discuss it later. We'll also discuss DHCP guys again, right? Because this is basic of DHCP. But DHCP is important protocol because in the production network, every time you will be using it DHCP, and you will configure many features there. Lots of features are there, right? So I have created one pool. How I can verify? Do so IP DHCP pool. You can see pool. Pool name is building 1. Utilization mark 0. Okay, leave it for total addresses. How many total number of valid IP addresses are there? 254. Correct, guys? List IP address, leave it for now. Excluded IP address? No, but I need to exclude one IP address, right? That is already configured on router number 1. So say IP DHCP exclude address. Exclude address. Which address? 192.168.1.254, which is my default gateway. I have already configured it on router. So I have exclude one. Again, I am going to run so IP DHCP pool. Now you can see exclude address. How many IP addresses are excluded? One. One is excluded. Right? Starting range 192.168.1.2, 192.168.1.254. So if PC1 will try to get IP address, let me check PC1 is able to get IP from DHCP or not. Actually, this is interface F0/0, so no set IP address. Let's suppose this is Cisco PC. So on the Cisco PC, you are running iOS. So on the iOS, you will configure like this. So I am running IP 190. Sorry, not IP address. IP address DHCP. So I'm saying please take one IP address from DHCP server. Debug IP DHCP. Done, guys. So IP interface brief. This machine have IP, right? Method is DHCP. And how PC1 have got the IP address from DHCP server? Tell me the process. Again, I am saying IP address DHCP. What happened? Got the IP address? Can anyone tell me the process? Complete process. Okay. When I have run command IP address DHCP interface F0/0 IP address DHCP, what will happen? Once I will hit enter. Oh my god. It will generate a discover message, right? Discover message. What will be source port number, guys, in the discover message? Random. Destination port will be what? 67 or 68? We have two port number for DHCP, 67 and 68. So destination port is going to be 67. Source IP Destination IP, broadcast. Right, then it will forward to switch, switch will forward to router. When it will forward to switch, switch is going to receive traffic on which interface? On E0/0. So it will learn MAC address. So if you will check MAC address table of this switch, so MAC address table, you can see I have one MAC address on E0/0 interface and one MAC address on E0/1 interface. So this is MAC address of PC1, because PC1 is connected with E0/0, and this is MAC address of PC2. And guys, how this machine have learned this MAC address? Method is dynamic. Type dynamic. Total number of MAC address in the table 2. Done. Later also you will have only 2 entry in the MAC address table. The reason, only 2 devices are connected with this switch. Am I right? Because this switch is not going to learn MAC address of this PC or this switch, this router, ASA firewall. This switch is going to learn either MAC address of router or this PC. So switch is layer 2 device, right? For LAN communication. Okay. Then guys, switch will forward to router 1. What router 1 will do? It will check first destination IP. So destination IP is broadcast. So see, router is going to accept packet in 2 cases. One, if destination IP address will match. Means if destination IP address is the IP address of my interface, of my receiving interface, then it will accept the packet. Otherwise it will discard it. Second scenario, if destination is broadcast. So this time in the discover message, destination is broadcast. So router is going to accept it at layer 3. Then it will check protocol field at layer 3. In the protocol field, value will be what? UDP na, so 17, 16. See guys, you guys are, you need to remember at least, 20 protocol and their port number. Important protocols. So destination is broadcast, it will expect it, accept it, and then it will check protocol field. After that it will identify upper layer protocol, and then it will hand over rest traffic to transport layer. Transport layer will check destination port. So destination port is port number of DHCP. It will check, okay, DHCP is enabled or no. Okay, if DHCP is enabled, then it will hand over the data to DHCP server. After that, DHCP server is going to generate which message? Offer message. Guys, tell me fast. Offer message. In the offer message, source IP will be what? Router IP address. Right? Dot destination. Destination. See, PC don't have any IP address, no? So definitely it will broadcast it. Broadcast. Broadcast. At layer 2, source MAC, router exit interface. Router is forwarding it, na? So MAC address will be the MAC address of exit interface. This interface MAC address. And destination MAC, guys. Why broadcast? Why broadcast? Because when router will receive discover message, it will run source MAC, na? It will make one entry in their ARP table that IP address is this one, MAC address is this one. So R1 know who have generated offer message at layer 2. but R1 don't know who have generated this discover message at layer 3. That's why at layer 3 it is broadcast. At layer 2 it will be PC1 MAC address. Okay. But in the Cisco operating system, again destination MAC will be broadcast. After that, router will forward it to this PC. Now PC will do what, guys? Again PC will check destination MAC. So destination MAC will match. It will remove Ethernet header. Then it will check type field in Ethernet header to know upper layer protocol. So there will be type code of IPv4. So it will remove Ethernet header and it will hand over IP protocol at layer 3. IP protocol is going to check destination. So again destination is broadcast. So it will accept and check protocol. So protocol is UDP. So it will remove the header and hand over the REST traffic to TCP UDP protocol. UDP protocol is going to check destination. So destination is DSCP. It will hand over to DSCP protocol. Once you have run command IP DSCP, that means DSCP service is enabled over here, guys. Right? If a device is receiving a traffic with a port number, let's say port number 443, and 443 is not enabled on this machine, so it will discard it. Who will discard it? Layer 4 will discard it. Transport layer will discard it. Still router have to process traffic till network layer. That's why we come up with multicast, because switch, router, 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 router. Guys, I have one packet here. If I want to send this packet to router 2, destination is broadcast. Let's say this is discover message. What switch will do? Switch will forward to these two routers also, right? And these two router will discard that packet at layer 4, right? That means router are still using their CPU utilization, correct? Because it is processing at layer 2, at layer 3. So to reduce this CPU utilization, we come up with multicasting technology. Multicasting. So that instead of sending on broadcast address, router 1 will send it on a multicast address. And as this interface is member of that multicast group, but these two interfaces are not member of that multicast group. So when it will forward to switch, switch will forward to again these two router. But this time at layer 2, destination MAC is the MAC address of multicast group. And this interface is not part of that multicast group. So it will drop the traffic at layer 2. So to reduce this CPU utilization only, we come up with multicasting technology. Multicasting is also, we will have around two classes on multicasting. Very interesting topic. Then guys, PC is going to generate what? Reply message. Again, reply message is broadcast. And then router is going to send acknowledgement. If you want to see all packet, I think here I can enable debugging. Let me do one thing on the router. Debug IP DHCP server, and let's say events. Now again I am going to request for IP address from PC. So say IP address DHCP. So this time you can see the process. Wait 1 minute. Let me do one thing here. First on the PC I'm going to say no IP address, because we have some IP address to messages for denying the IP address as well. Like if I am requesting for IP address to DHCP server from PC1 again, so PC1 have already one IP address, so first it have to release it. So PC is going to inform to router, because DHCP is going to maintain a table, so IP DHCP binding, right? So see, now this DHCP server have not provided any IP address, but if PC will get IP address, it will make one entry that I have configured this IP address to someone. It will make entry with their MAC address. See the entry. But now I am going to say no IP address DHCP to remove IP. Now show IP interface brief. Guys, you can see I don't have any IP, right? Because I have removed the DHCP configuration. So DHCP is not disabled on my client machine. Now I am going to enable DHCP. So it will request for IP address, and on the router you can see the process. Config interface F0/0 say IP address DHCP. DHCP sending notification of discover message. DHCP is going to first receive discover message on which interface, guys? On 0/0. So we'll see the rest information later. MAC address, allocating binding means it is maintaining a table. What IP address it have allocated? 1.5. Subnet mask, or to see all messages, what you can do, simply you can capture any link between router and PC. Do you want to see, guys, DHCP packet in capturing? Just wait, let me do one thing. Let me capture E0/0. Now on PC again I am going to say no IP address. No IP address DHCP. Now you can see the capturing between PC and router. So see release DHCP release message, because I have run command no IP address DHCP. So I am releasing one IP address. So DHCP is going to remove the entry from their table. Now see, I am saying IP DHCP IP address DHCP. Are you able to see discover message? Discover message. In the discover message, guys, source IP 0.0.0, destination IP, broadcast. Source MAC, PC1 MAC address. Source MAC is the MAC address of PC1. Even you can see it on switch as well. Like on switch is 0/0. Switch have learned what MAC address. So MAC address table. This is how we are troubleshooting in real time also. You will have console also, you will have capturing also. So actually switch is learning MAC address of PC1 on E0/0. In the discover message also you can see MAC address is same, right? Only representation is different, right? In the discover message, source MAC is the MAC address of PC1. This is my topology, bro, where you are. When PC1 is sending discover message to get IP address from DHCP server, so this is that DHCP packet. Source IP 0.0, destination IP, broadcast. Source MAC, MAC address of PC1, destination MAC, broadcast. Then next message is, and one more thing in discover message, After that, you can see UDP header. In the UDP header source port 60, destination port. So 68 is the port number of client. So here source port will be not random port number. Source port will be 68. So I have this is why I have two port number. One for DHCP client, one for DHCP server. And one important question of CCNA 200301, how to enable, how to make a router to DHCP server. So guys, command to make a router to DHCP server is IP DHCP how to enable DHCP pool, then you can create the pool. How to enable DHCP on client machine, what is the command? You will have multiple commands in option like IP DHCP, IP DHCP server, IP address, and then DHCP. So you need to find the correct command. So this is the command IP address DHCP, right? So with the help of the destination port, when router will see destination port is 67, okay, that means someone have sent message to DHCP protocol. Let me remove the header and let me hand over actual message to DHCP, and this is actual message. Here it is. This is actual message. So you have actual message, then transport layer. Here we can note see the protocols of presentation layer and session layer. We will have information of application layer, transport layer, network layer, and data link layer only. And as a network engineer, even you don't need to learn session layer and presentation layer because you are not going to work on those two layers. If you want to work on those two layers, you have to become a software engineer. Done. Then guys, we have sequence number and rest information. See, this is UDP, that's why we don't have any sequence number here. There is no flag, right? And in the IP header, see, protocol number is what? 17, means protocol number of UDP. So when router will receive it at layer 4, it will check destination port. Destination port is 67. Let me hand over to DHCP. When IP will receive, it will check destination. So destination is broadcast, destination IP broadcast. Then let me check protocol. Okay, UDP. UDP is working at layer 4. Let me remove the header and let me hand over to UDP like that. And how Ethernet later, when layer 2 will receive it will check what? Destination MAC. So destination MAC is broadcast. Let me check type. Type code is guys 0x0800. This is type code of IPv4. So if type code is IPv4, that means at layer 3 IPv4 protocol is running. So Ethernet is going to remove this header and it is going to hand over packet to IP protocol at layer 3. So from the physical layer, see, when router will receive discover message, it will receive at this layer in bits. Then it will convert it into frame and then hand over to Ethernet protocol at layer 2, Ethernet 2 header. So Ethernet protocol is going to open Ethernet header. It will check destination. It will check destination. If destination is broadcast or their own MAC address, then only it will accept. Otherwise, it will discard it. If destination is broadcast, then let me check type, because next information is type, where I need to send rest information. So type is in the type field. Code is IPv4. So it will hand over rest information to IPv4. Then IPv4 protocol will check destination. Again, destination will match. Then it will check protocol. Protocol is UDP. It will remove IP header and hand over rest information to transport layer protocol, means to UDP. UDP is going to check destination port. Destination port is 67. 67 is enable. Let me remove the header and hand over the actual information to DHCP. That's it. This is the only process. Then guys, your DHCP server is going to generate offer message. And before the offer, see, there is one ARP message. ARP message for 10.1.1.6. So who is looking for MAC address of this IP address? This one, 192.168.1.1, right? See the meaning of message now. Who has this IP address? Tell to this IP address. This is what default gateway. So default gateway have sent one ARP request message. After that, see the offer message. Guys, in the offer message again, it will generate offer message, then it will hand over to transport layer. Transport layer is going to add source port, destination port. So source port, this time this device is DHCP server, so source port will be 67. Destination port, it is sending to DHCP client 68. That's it. Then it will hand over to IP protocol at layer 3. IP protocol is going to add source IP and destination IP, which is broadcast. Source IP address is the IP address of DHCP server, and then it will add protocol. Who have hand over this to me? UDP protocol, right, from the transport layer. After that, after adding IP header, it will hand over to Ethernet protocol at layer 2. Ethernet protocol is going to add source MAC, destination MAC, and the type code of protocol who have hand over the rest information. Then Ethernet is going to hand over to layer 1. Layer 1 will forward it. Then my client machine will receive. Then client machine is going to send what? Request message. Request message. And in the request message, you can see what IP address this machine is providing. 192.168.1.6. In the offer also you can check IP address. What IP address DHCP is offering. So many more informations are there, right? Message type. So that's why I told you we will have one more session on DHCP. Okay, so I have 4 messages: discover, offer, request, and reply. So after receiving request message, again in the same way it will generate acknowledgement, means DHCP server will generate acknowledgement after receiving the request message, and this is how finally PC will assign the IP address. And again, before assigning that IP, it will generate what? Gracious ARP. This is gracious ARP to check what is it duplicate or not. If this is not duplicate, then only it will assign. So now you can see on PC. So IP .7. So latest. Okay, I have stop the capturing. That's why we are not able to see. So next IP address is this one. Earlier, previous IP address was this one. So for this IP address, it have generated one gracious ARP. In the gracious ARP also you can see this is gracious ARP message. Target IP address same. Sender IP address same. Target means destination. So who will generate reply to this message? This one, this IP address. This is how client machine is going to identify IP is unique or not. Again, it will generate gracious ARP at layer 2, then it will hand over to Ethernet protocol. And guys, this time see in the Ethernet source MAC, destination MAC, after that type code of ARP protocol. Why? Because this time Ethernet protocol have received message from ARP protocol. So upper layer protocol is ARP this time, not IPv4. Yes or no? Getting my point, brother? So it depends, type it depends on upper layer protocol. If it is ARP, then type code is going to be 0x0806, and any protocol can be there. ARPA protocol, ARP protocol, whatever protocol you have at layer 2. Why 2.5? Layer 2, no, brother? Where is 2.5? ARP, is there any IP header, guys? Are you able to see 0.5 IP header? Where is 0.5 IP header? We have actual information than layer 2. That means this protocol is working on layer 2. And we don't have 2.5 layer, brother. We have either 2 or 3. Either it can a protocol can be work on Ethernet header, or it can be work on network layer. There is no 2.5 layer. How? Oh my god, like, but brother, in OSI model I have network layer and then data link layer. So either a protocol can work on data link layer or on network layer. What you are saying? Between data link and network we have one more layer, that is 2.5, like that. No, I didn't get you, brother, sorry. ARPA also works at layer 2, not 2.5. ARPA, see, a protocol can either work at layer 2 or layer 3, brother, only. It is not possible to work on 2.5. Layer 2 protocol will hand over their data to directly Ethernet protocol. Layer 3 will hand over it to directly to IP protocol. Like OSPF is there, EIGRP. On application we have one protocol BGP, ICMP. These all are what? Layer 3 protocol. This protocol works at layer 3, and ARP, ARPA, triple P, these all protocols work at layer 2. There is not 2.5, so don't know how you are saying, but sorry brother, I don't know about it. Done. Yeah, this one. It's preferred to upper layer. Means, see, this is my PC. This PC is receiving a packet, let's say a frame where source MAC is MAC address 08, destination MAC is 0B, let's suppose, and type field is there, right? And guys, on the upper layer we have multiple protocol. Means at same layer we have multiple protocol: ARP, triple P, ARPA. At these are at layer 2. Then layer 3 IP, EIGRP, and many more protocols are there at layer 3 again, right? So see, Ethernet header is going to encapsulate packets of these all protocols as well as these all protocols, correct? So if at layer 3 protocol is IP, then type code is going to be what? Type code of IP protocol, right? If it is a message, it is encapsulating R protocol with this header, then type code is going to be what? Type code of R protocol. If it is going to encapsulate triple P protocol with this header, then type code is going to be what? Type code of triple P. If it is going to encapsulate ARPA protocol, type code is going to be what? ARPA protocol. If it is encapsulating IP, type code is going to be what? IP. So that when receiver machine will receive it, when receiver machine will receive it, it will get to know that after checking destination MAC, to whom I need to send REST traffic, right? So if type code is 0x800, then I will hand over to IPv4 because this is type code of IPv4. If type code is 0x0806, so you can see this is type code of ARPA protocol, then I will hand over it to our protocol. Got it? Yes. Not layer 3 na bro, layer 2 na. Type refers to layer 2. See na here, this is ARP message, ARP request. Gracious ARP is one kind of ARP message. Like this ARPA or any other message. And here type code is type code of our protocol. If upper layer protocol is layer 3, then type code will be IP. Then only if type code is a type code of a protocol which is working at layer 3, then ARPA is going to hand over it to layer 3 number, layer 3. So in my scenario, this machine is able to get IP address from DHCP server with the help of 4 messages: discover, offer, request, and reply. Now guys, this PC can ping their default gateway. Answer is yes, because so IP interface brief, you can see IP is correct, IP address is correct. So ping 192.168.1.254. And guys, see, DHCP have assigned this IP address to this machine. So method is DHCP. And if you want to know, if you want to check DHCP table here on the router, you can run command show IP DHCP binding, right? So here you can see which IP address is allocated, this one. If there are two PC who have assigned the IP address, then there will be two entry, right? For 254 IP address is 254 entry will be there. So ping this IP address and you can see I'm able to ping my gateway IP address, right? And guys, ping works. Ping uses which protocol? Ping uses ICMP protocol, and ICMP work at which layer? Hut. ICMP work at network layer, layer 3. So ICMP protocol is going to generate what? One ICMP request message. Yes. And after that ICMP protocol will hand over it to IP protocol to encapsulate it. So IP protocol is going to add source IP. Source IP will be IP address of PC1, means 192.168.1.1. Destination IP 192.168.1.254. IP address of default gateway, because I am pinging to my default gateway. Source MAC will be the MAC address of PC1. Destination MAC will be the MAC address of default gateway. But what will be type here? Type, guys. Sorry, not type. Protocol. In the IP address, we have protocol field. What will be protocol number? 1. Because who have hand over this ICMP request message to IP protocol? ICMP. So that's why ICMP protocol number. So receiver machine will get to know by checking this field. Okay, upper layer protocol is ICMP. So it will remove the header and then it will hand over to ICMP protocol. Then source MAC, PC1 MAC address, destination MAC, router 1 E0/0. What will be type code? Type 0x0800. Why? Because IP protocol have hand over it to ARPA protocol at layer 2. So in the Ethernet header, type field is going to be 0x0800. After that, physical layer will convert it into bits and then forward to router. So router will receive it at again layer 2. It will check destination. So destination will match. Then it is going to check type. So type is type code of IPv4. It will remove the header, then hand over to IP protocol. IP protocol is going to check destination IP. Destination IP will match. It will check protocol. So ICMP is enabled. It will remove this header and then hand over ICMP request message to ICMP protocol. Now ICMP protocol is going to generate one reply message, right? Again in the reply, source IP will be the IP address of router 1, destination IP will be the IP address of PC1, protocol will be 1. At layer 2, source MAC will be the MAC address of router exit interface, destination MAC will be PC1 MAC address and type will be type code of IPv4. Then it will forward to PC1. So when I am typing ping this IP address, that means my router is generating how many ICMP request message, guys? 1, 2, 3, 4, 5. Right? My machine is generating 5 ICMP request messages for one time. And see, I have got reply of all packets. That's why success rate is 100%. Right? I have sent 5 packet and received 5 packet. Round trip, we'll see these things later. Go ahead, go ahead. Hmm. Yes, ICMP protocol work at layer 3. Take one screenshot, brother. What important protocol I am saying here? Application layer. HTTP, HTTP, S, DHCP, DNS, Telnet, SSH. Transport layer, TCP and UDP. Network layer, IP, EIGRP, OSPF, ICMP, and many more are there. We'll see those later. Then a data link, ARP, GARP, and see again there are many types of ARP, so don't worry. ARP will see this. Will yes discuss ARP later. Means type of ARP later. Huh? Yeah, yeah. You can add those all as well, right? But guys, these are very important. So take one screenshot of it and don't ask which protocols works at which layer from these protocol even. And I am saying there is no 2.5 like ARP means layer 2. Layer 2 means layer 2. That's it. Done. So take one screenshot of it and you can see. So right now if I am pinging, that means my device is generating ICMP packet. How many ICMP packet? 5 ICMP packet. So it will get 5 reply messages. And now you how we miss devices are encapsulating the packet and this decapsulating the devices. Now guys, next thing is, see, I need to enable telnet as well on router so that I can configure router from here. Let's say PC1 is network engineer connected with this network to manage it. So PC1 need remote access of all devices. You need to enable telnet on switch also, router also, ASA firewall also, router 2 also, switch 2 also. For now, let me enable telnet on router 1. So command is, by default guys, telnet is enabled, but you have to configure password. So line VTY 024. Either I can configure password or I can say no login for now. No login. No login means there is no password. Anyone can access this router if they know IP address, right? Because there is no security, right now I'm not talking about security, so leave it. Right now telnet is enabled on router number 1 and anyone can access it if there is IP reachability. So from PC1 I am going to say telnet and my IP address of my router is 192.168.1.254. So you can see I have access of router 1. PC1, right? Telnet. So host name is PC2CR1. Now I am on router number 1. So guys, when I am typing command telnet, what will happen on this machine? When I will type this command telnet and IP address of router, First of all, which protocol will work at application layer? Application layer, telnet, right? So telnet protocol is going to generate one telnet request message. Then it will hand over to transport layer. Transport layer will add source port, destination port. Source port will be random port, destination port will well known port, but destination port, on the basis of destination port it will decide it is TCP based or UDP based. So okay, if port number is 23, that means it is TCP based. If port number is 23, that means it is a TCP based. So transport layer, you know how transport layer identify TCP and UDP with the help of port number. This is the reason why we have port number for the services. So when I will type telnet, telnet is going to generate one request message, then it will hand over transport layer will add source port, destination port, then it will hand over lower layer will add means network layer, source IP, destination IP and protocol will be TCP, then it will hand over to lower layer means layer 2, at layer 2 source MAC, destination MAC and type is going to be type code of IPv4, and then it will forward to router. Again on router number 1, telnet is enabled, so layer 4, layer 2 will check source, then after that type, then it will hand over to layer 3. Layer 3 is going to check again destination IP, then protocol field, then it will hand over to transport layer. Transport layer is going to check destination port, after that it will hand over to telnet, which is working at application layer. So on the application layer, telnet is saying, okay brother, just give me the telnet request, let me do one thing, someone is trying to access me, okay, let me check password is required or no. Okay, password is not required, just accept it. It will send one response message, it will accept it, and machine will get a remote access. If there is password, then first it is going to authenticate the user, it will ask for username, then your PC will ask username to you, right? Like on PC, sorry, on the router, if I can say line VTY 024 and password 123. Now if you will try to telnet this router, from PC1, what will happen guys? It will ask you for password. See what happened. Oh, no login command is running. Let me do one thing, let me remove no login command, line VTY04 and say login this time. So whenever someone will try to log in, it will ask for password. Exit and say telnet. See, this time it's asking for password. So you don't need to learn how telnet is actually working. Telnet is a protocol designed by software engineer. You need to learn how it's work on devices. So now if someone will tell you, brother, that see, you are the network engineer and you are not able to telnet router number 1, how you are going to troubleshoot it? Let's say you have enabled the telnet on router number 1, you have configured IP addresses on PCs, you have set up the DHCP, let's say, and then after that you are trying to access router number 1, but you are not getting access. You will check the configuration. See, after configuring the password even, it was not asking for password, so I have changed the configuration. So there are many features guys, lots of features are there in telnet that you need to learn to configure it in real time. This is simple command, 2 to 3 command I have run on router and PC. This is not enough, right? Like you don't know how many user can access my router at a time, right? How many user can access my router at a time through telnet? Because telnet is TCP based protocol. Suppose if so users are accessing router through telnet, what will happen? Router have to maintain so number of TCP connection, your router will start hanging, brother. So we cannot configure like this in real time, but this is how we can enable it. Okay, in real time I will have a separate server for authentication who is going to authenticate the user, because let's suppose this router is my DHCP server for 10,000 devices. Telnet is also enabled there, but password is not configured there, so anyone can access. What if 100 people will, and if you know someone knows your password, it is not difficult to find sorry, password on router, guys, right? I can find what is the password on router. See, if I have access of router, I can simply one I will simply run one command here, so run and include only line VTY. It will show me the password. Password is 123. So anyone can attack on your router. This is one kind of attack, right? Attacker is disturbing your network. Attackers are sending fake SYN messages. Even from a single machine, from this computer, you can send 10,000 number of TCP requests to router at a time with the help of application. So attacker can install that software. They can send 1,000 number of SYN message to your router. Your router is now busy to maintain those connection table. Now what someone will try to get IP address from DHCP server. Getting my point? So we'll not configure like this. And by the way, telnet is not secure. But this is what how telnet works. When I am typing command or when a client machine requesting to get IP address from telnet, sorry, from DHCP server, or when client machine is trying to telnet access of a router, how packets are moving, which layers are generating traffic, how transport layer, network layer, and data link layers are providing encapsulation, what is protocol field, what is type field. So in the capturing, when you will capture the link in real time while troubleshooting, see how much it is going to help you to identify the upper layer protocol at layer 2. You can check at layer 2 which protocol is, means upper layer protocol is IPv4 with the help of type code. So these are important field in IP header, protocol field, in the Ethernet header, type field. Now guys, see, I have IP address, I have default gateway, I have DNS server IP address, I can ping my default gateway, but can I ping PC2? Answer is no. So when I will ping to PC2 192.168.2.1, see which device is dropping my traffic? Which device is dropping my traffic? No, bro, no firewall. See guys, when I am pinging to this IP address, again PC is going to generate ICMP request where source IP will be 192.168.1.1, destination IP 2.1, source MAC PC 1 MAC address, destination MAC R1 MAC address. It will forward to router. Router is going to check destination IP. Destination IP 192.168.2.0. Router is going to check their routing table. It will run this command. So IP route, and then it will compare the destination with routing table. Is route available? No, I have only one route for this network, 192.168.1.0. Means the use of CIDR value here. /24 means what? Means this router means what? Means 24 bits should be this one only. 24 bits should be This, yes, same, right? So if there is one IP address with 192.168 dot, let's say 1.50, so this IP address is matching over here, right? Because 24 bits are same, 24 bits are same, so it will check only 24 bits, right? If there is 25, guys, that means it is going to check 25 bits. 25 bits should match, and it will ignore rest bit. But here you can see only 16 bits are same, right? In third octet value is different, so it is not matching, so simply router will drop it, right? So the solution, here I need to configure one route, so I can say IP route and the destination network, which network you want to inject in the routing table, what network you want to add, 192.168 dot subnet mask. Now tell me from which interface this network will be reachable. Yes, next hop will be what? Firewall. So what IP address on firewall will be next hop? 2 2. Router is going to install this network in their routing table, right? And it will forward traffic to this IP address. So actually I have to tell to router that this network is reachable from which IP address. So either I can say this is reachable from E0/1, but there is some disadvantage of it, we'll discuss later. Next is I can say 192.168.0.2. Now again there is some disadvantage of it. So in real time we will provide both exit interface as well as next hop IP address. So next hop IP address is this one, and exit interface, guys, is 0/1. What happened? Here I cannot add exit interface. First I have to add exit interface is 0/0, then IP address, like this. Done. Now again you can check routing table. So IP route. Now there is one static route. This S means what? Static, right? C means what? Connected. L means what? Local, means my IP address. So whenever destination is going to be this IP address, so here you can see there is one another route. Here it is going to match all 32 bits. If all 32 bits will match, that means traffic is for router. So this S means static. Here also you can see. And then which network I have? 192.168.2.0/24. This is AD value, this is metric, we will discuss later. And you can see this network is reachable via 192.168.0.2, which is IP address of ASA firewall. But guys, question is this interface reachable? Is this IP address reachable? Ping 192.168.0.2. Is this IP address reachable from router number 1? No, because I have not configured anything on firewall till now. So can PC1 ping? Still no. Again, which device is dropping the traffic? Your router. Reason? Next hop is not reachable. Route is available. See, this time it will compare destination in the routing table. This time, okay, route is available. Next hop is 192.168.0.2. This router will find MAC address of this next hop, so it will check ARP table. In the ARP table, there is no entry. There is no entry for 0.2, 192.168.0.2, right? So this, so IP interface brief. There is no entry. It will generate ARP. But guys, we didn't configure ASA firewall interface. So that's why my router is dropping the traffic, because my router is not able to resolve MAC address of next hop, right? First of all, let me disable the debugging for DSCP here. So let me do one thing. Let me configure one IP on ASA firewall. So can access the firewall, go to config t, and then interface, host name, ASA firewall. Then guys, interface G0/0. Here I am going to say name if. Name if means inside or outside which type of interface it is. We will see the use of name if command. Then as I told you, in firewall we need to configure security level, and by default higher security level to lower security level traffic can flow, but from lower security level to higher security level traffic cannot flow. Traffic are not allowed. By default higher security level to lower security level traffic are allowed, but lower security level to higher security level traffic are not allowed, right? So here I am going to set security level 100, then say IP address. What IP address? 192.168.0.2, 255.255.255.252. Now can I ping this IP address from router? So IP interface brief. Can I ping? No, because we didn't configure any IP address on E0/1 of router 1. Correct? So we need to configure this interface also. Interface E0/1, no CERT, no switch port, and IP address. IP address 192.168.0.252. Now can I ping firewall 192.168.0.2? Will ping work? Question is why ping is not working? I can do one. Default gateway. See, PC1 is able to ping their default gateway, no brother? ASA firewall IP address. This one. I am not able to ping next hop. How you will troubleshoot it? So IP interface brief. So IP is line protocol is up. On ASA, so run interface G0/0. See the running configuration of ASA firewall. Command is shutdown. So interface G0/0. No, what happened? Config T interface G0/0 and say no, shutdown. Can router ping to their next hop? Working. Correct. Can PC1 ping firewall? Ping 192.0.2. Why ping is not working? Actually, this is part of firewall. Don't worry. By default, firewall allow only TCP traffic. So here I am going to say fix up protocol ICMP. So I have allow ICMP protocol as well. Still it's not working. कहाँ पे? ऐसे पे ले लिया ना, कर दिया है ना, फिक्स अप प्रोटोकॉल ICMP. Why ping is not working, guys? Tell me fast. How you will troubleshoot? So IP ARP. Is this machine able to resolve MAC address of default gateway? Yes. Right? Go to router. So IP route. Right? This network is available. So destination IP will match in this network, correct? Destination IP 192.168.0.2 will match in which network, guys? Because lots of subnets are there in the routing table. Tell me, this IP 192.168.0.2. This IP address is matching in which entry? In this entry also matching or not? Bro, no. Because in third octet value is 0. Here value is 2. Here it's matching. So it will odd packet from E0/1. Router 1 is going to odd packet from E0/1. Let me check. It is able to learn MAC address. So IP ARP. Yes or no? Yes, this machine is able to learn MAC address of default gateway. That's why it is able to ping 2. Then still ping is not working, but ping should work. Then PC to ping 192.168.0. Ping below. Ping should work. Let me do one thing on ASA firewall. I'm going to check it is receiving ICMP packet or not. See how I am troubleshooting as well. Debug ICMP. Now again I am going to ping. See, ASA firewall is generating reply. Are you able to see the request message? Why ASA is not generating? Okay, issue is ASA firewall is not generating reply. It is receiving request message. 1, 2, 3, 4. Why ASA is not generating ICMP? I have fixed up the ICMP protocol as well. So route destination. When ASA firewall will generate reply, destination will be 192.168.1.1. Is this IP address matching in an entry? So route is not available. What ASA fire will do? It will discard it. So I need to configure route on ASA firewall. What I need to do here, say config t and route 192.168.1.0 subnet mask 255.255.255.0. And one more thing here, you have to specify that I am configuring this route on inside interface. And next hop IP address, guys, 192.168.0.1. For ASA firewall, who is next hop? Router 1. Now you can see show IP, show route. Now source matching PC1. Yes. Now can PC1 ping to firewall? Yes. Ping is working. Success rate is 100%. In the same way, you need to configure this side also. So I will come tomorrow by configuring these devices. Okay, go ahead. No physical layer. Where is physical layer? At physical layer, there is no header, but no information on it. Data link layer have header, Ethernet header. Anyone else? Anyone else is not clear with our layer to data link layer? Is there anyone? Tell me guys frankly if data link layer is not clear to you. Data link layer? Yes. Hmm. Not now. After the routing, we'll do lab on multicasting. And see how Ethernet header look likes. Is it visible? Is it visible? Is it visible now? So see what information you have in Ethernet header, brother. Don't worry about the preamble. This is just a field in data link in Ethernet header, and frankly, I'm saying not important field. And later you will automatically understand the use of preamble field here, right? But this field is going to tell machine from where data is starting. Then there is one checksum field which is used for error detection, as we have checksum field at transport layer by running algorithm, remember, right? It will put the data in algorithm and it will find one hash value and it will add that hash value in this field. So destination machine will also do same thing. It will put the data in algorithm and it will find the hash value. If hash value will match, that means there is no modification. Data is unmodified. If hash value is difference, that means data is modified. Then your actual data, this is what other protocol have hand over to Ethernet header, right? And other protocol can be IP protocol from layer 3, it can be R protocol from layer 2. Done. Then there is one information that is length, who is going to carry length information, length of header. Then source MAC address, destination MAC address. Only these informations are there in Ethernet header. What you want to learn more? Source address, destination address, about the length, about the data, what? Yes. And type field is also there. See, this is older version of Ethernet header. See this header, bro. These informations are important. And latest Ethernet header. There is one type field, right? This type field. Source, destination MAC, source MAC, then type field. So this type field is going to carry upper layer protocol information, right? So if data, it means Ethernet protocol, Ethernet means ARPA protocol is working here. If ARPA protocol will receive traffic from IPv4, from IPv4 protocol, then type code is going to be what? Type code of IPv4 protocol. If ARPA protocol is receiving traffic from IPv6 protocol, then type code is going to be type code of IPv6. If ARPA protocol is receiving traffic from R protocol, then type code is going to be type code of R protocol. And each protocol have one type code. to identify that protocol at layer 2. How ARPA protocol identify upper layer protocol, that is type field? Yes bro, tell me. And it is 2 bytes information represented in hexadecimal. So value can be what guys? 2 bytes information means 16 bits. Means how many characters are there? 8 characters. So if 8 value is 000, that means lowest type code. And if all are FFF, that means it is largest type code value. Got it? See, length of type field is what? 2 bytes. So lowest type value can be what? 8 times 0. 8 times 0. Why 8 times 0? Because not 8 times, sorry, 4 times. 4 times 0. Extremely sorry. 16 bits. That means each hexadecimal value carry 4 bits. That means we have only 4 character. So 0000 or FFFF. All type value is going to belongs from this range. And IPv4 have what value guys? 0x 0800. Right? So this is representation, different representation in Cisco operating system. So type field is nothing, brother, which I, yeah. Total length, total length of header. 6 byte MAC address source MAC, 6 byte destination MAC, 48 bits, right? 2 bytes, 4 byte, checksum for array direction. So total length of header is guys, this is minimum length of header. For our packet value will be 0x0806, type code of our protocol. I have already shown you these things in capturing, I think, brother. Oh my god, you guys didn't see this value in our packet? No, what about others? Yeah.